we have been talking about ways to ways to make complicated computations simpler and more manageable. And that's what we've been working on in our number talks. So I wanted to go ahead and go into the distributive property because it's a really great way to break up the parts of the expressions and again just make something that looks complicated, just make it more simpler and more manageable. Okay, so I wanted to go ahead and look at this particular problem here. So we've got here, it says try this. Move all of the expressions to the left to the correct column on the right that represent the area of the large outer rectangle in figure B. So, I'm going to have you guys look at that on your peer deck, but I want to go ahead and go over this with you before you move it around, okay? So, one of the things that I want to show you is that with this 6 times 3, you may have at some point looked at that as, so this would be 6 rows, okay? So this would go like this, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And they're not to scale. As you see, I did not use a ruler to kind of measure it out. Okay, and then this would be 3 wide here, and this would be 2 wide. So if it was 3 wide, I could easily just go like this. Okay, so you've seen that before, and it kind of breaks it up. And then this would be 2 wide, right? Because 6 tells me there are 6 groups. 1, 2, 3, 4, 5, 6. This down here tells me there's 3 groups. This down here tells me there's 2. Okay? So if I were to go ahead and count all of that, I would say there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, but that's kind of a lot of counting, right? The other way to do it is I could say this square would be 6 times 3, right? 6 times 3. And what is 6 times 3? That is 18. Okay? And now, so that means that this rectangle is 18 squares. We counted it, and then we multiplied it, we confirmed it. So over here, I'm going to do something very similar. We're going to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 times 12. 6 times 12. Well, that also, 6 times 2, that also equals 12. So 18 plus 12 equals 30. Okay, we see how that is. We would add this side up, and then we would add this side up, right? And we would get a total, this whole big rectangle would be 30, okay? So let's look at it the distributive property way. So we would first look at 6 times 3. Okay, that's this side here. And then we would look at this side here, which is 6 times 2, right? We just add the two together. So, okay, so I could see where that's the 18 and that's the 12. That's great. Let's go ahead and take one of those steps away. Why don't we go ahead and take away that common factor of 6. And we're going to put that on the outside of the parentheses. So we're going to say 6 times 3, just moving that plus sign down, plus 2. 6, right, times 3 plus 2. Okay. All right, so that would be 6 times 3 plus 2 is 5. 6 times 5 is 30. All right. So it looks like I'm getting the same answer. Counting, multiplying, we got 30. So we got 30 there, we've got 30 there. So now what I want to do here, based on these instructions, we need to compare with what's over here. Okay, we can do that. That's not going to be a problem for us. So let's go ahead and first look at the first expression over here. Okay, well, this looks familiar. That's the same thing that we wrote over there. 6 times 3 plus 2, that's 5. That equals 30. 6 times 5 equals 30. So, there we go. That is a true representation. So let's look at this one. 6 plus 3 is 9, plus 2 is 11. So that equals 11. So that's not going to work. Let's try this one. So I've got 6 times 3. 6 times 3 plus 6 times 2. Yeah. Okay. Yeah. That equals 30. We've done that same one, so I can see that. Let's try this one. 6 times 3 plus 2. Wait, they forgot the 6 times 2. So we already know that's not going to work. 6 times 3 is 18. 18 plus 2 equals 20. Okay? We actually didn't even have to go. It was just kind of a double check. And then here we've got another one. 6 times 5. Yeah. 6 times 5 is 30. All right, we know that one worked. And here we go, we got another one again. So we have 6 times 3 times 2. Well, no, you're supposed to add the 2, right? So 6 times 3 is 18. 18 times 2 is 36. No, that's not going to work. So we've checked each one of them, and we have found that there are 3 that we've made them all a little bit less complicated. If you just break it down and go step by step, you can find that using the distributive property, you can make something a little bit more manageable, okay? So one thing that you will want to remember is that with the distributive property is that distribute means to multiply what's inside the parentheses. Okay? So I don't want you to forget to do that. That's very important, right? Just like we did up here where we had 6 times 3 plus 2, okay? We could do this 2 ways. We could add it. You saw that we did that. But we could also do this too. 6 times 3 is 18 plus 6 times 2 is 12. And we got 30. It was the same thing we did all over there. Okay? So now we're going to also continue to work on using this distributive property and how we can actually use it in the real world situations. Okay?